of state. Matter normally exists in three states: solid, liquid, and gas. A transition from one of these states to another is called a change of state. These changes can occur when the exchange of heat takes place between the substance and its surroundings. Take some cube of ice in a beaker. Note the temperature of ice 0 degrees Celsius. Start heating it slowly on a constant heat source. Note the temperature after every minute. Continuously stir the mixture of water and ice. Draw a graph between temperature and time. In the above process, the temperature of the system does not change even though heat is being continuously supplied. The heat supplied is being utilized in changing the state from solid ice to liquid water. The change of state from solid to liquid is called melting, and from liquid to solid is called fusion. Both the solid and liquid states of the substance exist in thermal equilibrium. That is, no change in temperature during the change of state from solid to liquid. The temperature at which the solid and the liquid states of the substance in thermal equilibrium with each other is called its melting point. The melting point of a substance at standard atmospheric pressure is called its normal melting point. Let us understand the process of melting of ice by an activity. Take a slab of ice. Take a metallic wire and fix two blocks, say 5 kg each, at its ends. You will observe that the wire passes through the ice slab. This happens due to the fact that ice just below the wire melts due to increase in pressure, which causes very less variation in temperature. When the wire has passed, water above the wire freezes again. Thus, the wire passes through the slab and the slab does not split. This phenomenon of refreezing is called regelation. Skating on snow is possible due to the formation of water below the skates. Water is formed due to the increase of pressure and it acts as a lubricant. When the temperature keeps on rising till it reaches nearly 100 degrees Celsius, where it again becomes steady. The heat supplied is now being utilized to change water from liquid state to vapor or gaseous state. The change of state from liquid to vapor or gas is called vaporization. It is observed that the temperature remains constant until the entire amount of the liquid is converted into vapor. That is, both the liquid and vapor states of the substance exist in thermal equilibrium during the change of state from liquid to vapor. The temperature at which the liquid and the vapor states of the substance exists is called its boiling point. Let us understand the process of boiling of water by the following activity. Take a round minus bottom flask, more than half filled with water. Keep it over a burner and fix a thermometer and steam outlet through the cork of the flask. As we start heating the flask, you will find that the air which has dissolved in the water will come out as small bubbles. Later, bubbles of steam will form at the bottom, but as they rise to the cooler water near the top, they condense and disappear. Finally, as the temperature of the entire mass of the water reaches 100 degrees Celsius, bubbles of steam reach the surface and boiling occurs. Although the steam in the flask may not be visible, but as it comes out of the flask, it condenses as tiny droplets of water, giving a foggy appearance. Now, if the steam outlet is closed for increase in the pressure in the flask, you will notice that boiling stops. Hence, more heat is needed to raise the temperature for boiling to start. Thus, boiling point increases with increase in pressure. Now, remove the burner and allow water to cool to about 80 degrees Celsius. Remove the thermometer and steam outlet. Close the flask with the airtight cork. Keep the flask turned upside down on the stand. Pour ice minus cold water on the flask. Water vapors in the flask condense, reducing the pressure on the water surface inside the flask. Water begins to boil again, now at a low temperature. Thus, boiling point decreases with decrease in pressure. Now we can explain why cooking is difficult on hills. At high altitudes, atmospheric pressure is lower. At high altitudes, atmospheric pressure is lower, reducing the boiling point of water as compared to that at sea level. On the other hand, boiling point is increased inside a pressure cooker by increasing the pressure. Hence, cooking is faster. The boiling point of a substance at standard atmospheric pressure is called its normal boiling point. There are certain substances which normally pass from the solid to the vapor state directly and vice versa. The change from solid state to vapor state without passing to the liquid state is called sublimation, and the substance is said to be sublime. Example: dry ice solid, CO2, iodine, etc. During the sublimation process, both the solid and vapor states of a substance coexist in thermal equilibrium.